the sheet and a magnet is there right in front of it. It is placed in front of a strong magnetic pole. Force is needed to hold the sheet if it is magnetic. Yes. So in first, because you see this, since this is magnetic, so immediately what will happen is it will start aligning with the magnetic field. So it will form, the sheet will form south pole here, north pole here, and what will happen is it will get attracted towards this magnet. So now if it is magnetic, then we require to hold the sheet to keep it in its position, otherwise it will get attracted. So here force is required. Second, hold the sheet if it is non-magnetic. So non-magnetic means it doesn't have no effect of magnetic field on that particular substance. Just like a magnet is there and you bring it near a piece of wood or plastic, what is going to happen? Nothing. So therefore no force is required. So here no F required. C, move the sheet away from the pole with the uniform velocity if it is conducting. Yes, here in the C part, if you see, move the sheet away from the pole. Okay, so the sheet is basically moving away from the pole and velocity is uniform, and it is a conducting thing. Now conducting means that there is possibility of current can flow. Now if you see this magnetic field inside, which is due to the magnet, is producing magnetic flux, and since it is producing magnetic flux, so we have this formula, phi is equal to B dot A. Now since this is producing magnetic flux because it's conducting thing, so now the change in magnetic flux will cause current to be developed in this sheet, and this current is technically known as eddy current. Okay, so what will happen is that eddy current will be developed, and now due to this eddy current, what will happen is, you see, it is going away. So since it is going away due to the eddy current and the Lenz's law, it will oppose the factor which is producing change in the magnetic flux. So therefore the eddy current will be produced in such a way that this conducting sheet, it gets attracted towards the magnet. So the current will be produced in which direction? How? So the current will be produced like this. Okay, and this will be the direction of the eddy current produced. Okay, so this is going to be north, this is going to be south, so therefore there is going to be attraction, and thus here also force is required to hold it. Okay, we can little bit understand it, little bit more details. You see here what is happening. Okay, the phi is decreasing because it's like going away. So since it is going away, phi is decreasing, so therefore the current will be induced. So I induced will be in this direction, so that the magnetic field is in this direction. Okay, because magnetic field due to the magnet, magnetic field due to the magnet was in this direction, and it is reducing, the intensity of the magnetic field is reducing as it is moving away. So therefore this is the magnetic field which is going to be induced by the current. Okay, and this, so like any loop which is having current like this will be equivalent to, okay, the right hand thumb rule, it's north pole and south pole, and here already there is a bar magnet with a north pole here, so therefore both will get attracted. Okay, so now in order to keep it moving with velocity v, we require to oppose this force. This force has to be opposed, and thus we require a force to move it away. D part, move the sheet away from the pole with uniform velocity if it is both non-conducting and non-polar. Now if it is non-conducting, then there is no effect. Okay, so now nothing is going to happen. So therefore we saw A is going to be the option, and also C is going to be the option. So therefore the answer will be A, which is A and C only. Thank you.